This is the final piece of the puzzle for section 8.6, and we are going to do some basic transformations of 1 over x. Now, how would you take, let's do this, you don't have to write this down, just give me some feedback here. How would you take the square root of x and shift it right 3? Where would you put the minus 3? In here, right? That would go right 3. Meanwhile, how would you take x squared and shift it down 4? You put a minus 4 where? Outside at the end, right? That's a review of unit 4. Shifting up, down, left, right. The left and right is done right near the x, while the up and down is after the parent function, after the squaring, or the square rooting, or the 1 over xing. All right? So that'll come into play right here. Translate the graph right 3. How do you think we do that to 1 over x? The x minus 3 goes together in the bottom. If you want to put it in parentheses, I would suggest that, especially if you're trying to put that on your graphing calculator. So let's try it. Let's put the denominator, x minus 3, rather than just 1 over x. Use parentheses, x minus 3. Close them. If you graph it, it should now be to the right 3. All right? It has now moved right 3. And since the graph moved right 3, what else moved right 3? The asymptote. So wherever the graph goes, you take the asymptote with it. So since the graph slid right 3, which asymptote moved to the right 3? X equals 0 or y equals 0? X equals 0. If you go down to the bottom, it says write the equations of the asymptotes. Normally, on the parent function, you can write it in the space here. In the parent function 1 over x, the asymptotes are 0 and 0. But if the graph slides right 3, the new asymptote is x equals 3. If it did not slide up or down at all, did the y asymptote change? No, it stays at 0. So those are the new and improved asymptotes for that graph, for the graph of number 1. Make sure you understand these asymptotes go along with this equation. All right? So they're tied together right there. So here we go. Now we have number 2. Translate it down 4 and right 2. Someone take care of the right 2. What does that? Minus 2, and then down 4. So while we're at it, the x asymptote slides right 2. So instead of being at 0, it's at 2. The y asymptote went down how many? 4, so it's at negative 4. It reminds me of finding the vertex of the parabola. When the parabola slid right 2 and down 4, there was a vertex at 2 comma negative 4. Okay? For vertically stretching and horizontally stretching, you do the same thing. You put the number that it's stretching by in the numerator. So to make this stretch by a factor of 2, it's 2 over x instead of 1 over x. It has no effect on the asymptotes, so they stay at 0, 0. You're just making the hyperbola larger. Whether the scale factor is 2 or 3, or whether it's horizontal or vertical, you put that number in the same spot. You put it in the numerator, 3 over x, and then how are you also going to move it up 2? Plus 2 on the back end. So shifting, that's not an 8 right there. That's a 0 and a 0. Sorry. For number 4, the x asymptote is unaffected. It only slid up how many? 2. For number 5, to reflect it, what's your hunch? Make it negative and just put the negative out front. Negative 1 over x. All right? Put the little slash like that. Negative 1 over x. It's fine. Asymptotes, unaffected. What happens is, instead of the graph living in quadrants 1 and 3, it flips to 2 and 4. So your homework tonight, in case you haven't seen it, it is listed right here. At the bottom, this is my conclusion. These are the things we learned today. Hopefully you agree that you learned those things. Do these pages, page 494, 1 to 4, and the green packet, 8.6, numbers 1 and 2. That's posted on Dashboard, and have fun with it.